T. Clark here, and this video is going to go over how to checklist your code, how to go through your all your code and make sure it meets the requirements for the create task using my samples. So first of all, let's go back to my web page. The submission requirements are here. The slideshow will be down here on the right, and I'll put the video up right here. But the submission requirements has this nice checklist that I made. You can click on, you can use a template and go through it with your own code to make sure you meet all the requirements for the program code, for the video, and for the PPR. But for this this video, I'm going to go over and do the checklist as if it's my own, or if I'm checking it, my own code that I did. So here's my most recent sample. So I have all my stuff. I have my written responses that I did a while back. I have my PPR. If I scroll down, here's my full program code PDF, and then here's a video. So, excuse me. For context, my program was to allow the user to change the polygon. So it first starts with the quadrilateral, and you can move an edge around or a vertex around and modify it that way. Or you could add and actually remove vertices. So I think in the video I add a vertex there, added another vertex, added a vertex. So my program allows users to mess around with different polygons and modify the shape however they want. And so that's my video showing the user is interacting with the program. Has input and output. The output is based on the user's mouse press. We'll get to that when I get there. Okay, so let's go through the slides. I don't know if I can make it full screen, but I'll make it as large as possible. So checklist your code using my examples. So first off, if you go through the checklist, there has to be input from the user, and that's my on mouse press. So I have that. So checklist, and you'll need one of these. You could have more, but you only need one to fulfill this section, the input section. And then output is visual. In this case, when the user clicks, either adds a point or it changes the point. So that's what happens in the video, and it shows it in the video. You could have textual being like the command prompt prints out the answer, like if you're doing math or a Wordle or something, and it prints out you got the first two letters right, the third letter close, and the fourth letter wrong completely, or something like that. But output has to be something that happens in the video, so I got that, so good to go. Then I have my list. So in my case, my list was the shape.point list. I have a few lists in here, and you want to make sure you remember which list you're referencing when you do your written response. When you go into the exam and you're writing about your written response, it'll ask about the list. It'll probably ask about the list, and you have to make sure you know which list it is. So in my case, I'm appending either the X and Y coordinates from the user, or I'm appending the previous points in the shape. So I'm basically remaking the polygon using these shape points, shape.pointList list, and then I get new points, and then I assign the shape.pointList to the new points. So I'm assigning it there, or maybe down here, down there. So I'm having the data being stored in the list. That's good, check mark. And then I have the data being used. The easiest way to get this point is for data being used is to have a loop going through the list. You could say for point in shape.pointList, or in my case, I'm using an indexed for loop, where I say for I, the index, in range, the length of the shape.pointList, excuse me, and then I'm accessing those points. In this case, 0 is X and 1 is Y. There's the rest of the line it wrapped around. So I'm using that list in this for loop. So I'm managing complexity because I don't have 10 different variables for the 10 different vertices I eventually have. I have just one list, and I'm accessing it using this loop. So that's one way to use it. There's other ways, but that's an easy way to get the points. Then my procedure, you have to have the name, so it's whatever's after the def. So my procedure is change point, check mark, there's my name. I have parameters. Remember, the parameters are in the parentheses. So my parameters are shape, point index, X value, and Y value. I think the X and Y's are from the user. I have the shape is just the shape, and then the point index is whatever index I'm changing. So you saw I was able to move it around. I changed the different points of the quadrilateral in the video. So I was able to use that point index, and actually that's right there. So the parameter has to have an effect. So in this case, I'm making sure the point index is part of an if statement. So one of these parameters should be part of an if statement. So if the index is the point index, I'm saying, so if that's the point I'm changing, or the user is changing, then that's the one that is new, and all the rest are copied over. But in this case, I have my parameter, a bunch of parameters, but one parameter that's being used in an if statement. So that's my check mark right there. I'm skipping sequencing right now. Selection is that if statement. You don't have to have the same if statement. It'll often talk about the written response will ask you to write about the first if statement, the first selection statement. That's the if statement. So selection is if. So you want to make sure your first one is what you write about, not just whichever one, but the first one. If it says what is the first selection statement, blah, 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 in the prompt. And then the next one is has iteration, and that's my for loop. So I have a for loop right there. So you could have a while loop, for loop. You could have recursion, don't worry about recursion, but for or while take care of the loop. So I have one, so that's good, and it's in my change point procedure function. There we go. And then because I have more than basically one line, everyone gets the sequencing. So you have to have sequencing, selection, iteration, and as long as it's more than 2 or 3 lines, maybe 3 is the max or the minimum you can have, but as long as it's a good function, you should have sequencing. So if you have selection and iteration, you automatically get sequencing. So don't worry about sequencing too much unless your function is too pathetic, honestly. And then I have my call. So I scrolled down on the code PDF, and my call is way down in the on the mouse press. There's my change point, so it matched the name that I had before. So I go back up the slides. I have my name, def, change point, and then my call has to be the exact same name. So later on, where's my call slide? Here we go. Change point. I have some place where I have the shape, the index, and the mouse X and mouse Y. So I have you have at least one call in your program. So here's my call in my program. And then a return, if I go back up to my function, there's no return here, so you don't have to have a return. It's not required, and so that's basically, don't need that point. So you still get the green completion color if you have everything except for the return type. And then a PDF, you should know how to make a PDF. Your teacher should have told you, but in CMU, you basically just print and then save as PDF. And you do want the comments, the green comments in CMU's case, you want the comments in the PDF. Yeah, so then you have the PDF, make sure the font's not too small for that. And then the next section is the video. I showed the video at the beginning, so it has everything as input, output, shows off what my program does. It's running continuously. It's not like slides or code or anything. It doesn't have the code, so you don't want to. You could have a little bit of code, but don't be scrolling in your code. Your video should be focusing on the output, on the either command prompt or the video output or the graphical output area. No voice narration, nothing distinguishing about yourself. The file name probably shouldn't have my name there, but that's just how I name my stuff. When you submit it, they'll change the file name, I think, when they grade it. Okay, last part, PPR. So first thing, no comments anywhere. So CMU has a nice thing where you can, when you're printing out the code, you have an option to toggle the comments. Otherwise, you have to go back and you have to delete all the comments when you take the screenshots. So this is for the screenshots, and you notice in my PPR, I pasted it into a Google Doc. There's no comments. You can see there are spots where I had the comments, maybe in my in certain parts, but they're gone. So like this extra line right here, extra line right there, it had a comment. But if you have extra lines, that's fine. Don't worry about extra lines, but there should be no comments. Font, at least 10 points. So I recommend using a template. So I use this template, my own template I had. Then all the fonts up top for the headers are 10-point fonts. And then I have to make sure the code, the screenshot code, is bigger or at least the same size as this blue text. So that's good to go. If you want to, I have a what is it called? I have I have a 10-point font PDF. You can look at the PDF and compare it to your PDF. Make sure they're like the same zoom in on your computer, or print them both out and make sure they are big enough text. Next thing is my procedure. So I have the whole procedure, the same thing we did, or I talked about up above in the checklist. So I have the entire procedure here, starting with that def change point. So that's my procedure. If you have a procedure calling another procedure, so you have sub-procedures that have important stuff, those all go in this section as well. But I only had this, so that was it. and then the procedure call. You can add some context around it. Also, I recommend having the line numbers. That way, when you're writing about your code on the prompt on the exam day, when the prompt says, what's the first if statement in your procedure, if I go back up one slide, I would say, okay, on line 17, what's my conditional in the procedure? I would say on line 17, my first conditional is if I equals point index, blah, blah, blah. So I'd use that line number. I would quote that line entirely as well. But line numbers help you focus and help the graders focus as well when you're writing about it. So either way, for the procedure, show where the procedure is being called. Here I have my change point, exact same word as my def. And I used context around it. Maybe I didn't need to include all this code. Right, so the user could only click the top part because of the bottom part has maybe a graphical user interface. So I'm letting the user move the point around, or I'm letting the user change the point entirely, depending on the mode for the program. So I have the call, that's good. You only need one call. Later on in the prompts, it might ask you to hypothesize about 2 calls. And even if your code only has 1 call, you need to make up the second call. That's fine. You just put in different shapes. So I could say change point, quadrilateral, index is 3, mouse X is 50, mouse Y is 50. Then another one would be change point with a triangle, app index is 2 or 1 or 0, and then mouse X could be 20 and mouse Y could be 0, maybe. So you're making that up. If it says you need 2 calls in the prompts, you can make those up. But the one call in this PPR is your code. It could just be 1 line. But again, I'd recommend including the line number, even if you just have the 1 line in the screenshot. Okay, list, same list I have. So my code is kind of complicated, complex, because I'm making a new list. Excuse me, what's going on? I'm talking too much in the morning. And then because I have a new list, I'm appending to that list, and then at the end, I'm setting my shape.point list to that new points list with the appending. So I included all of that in my screenshot. You do not just want new points equals bracket bracket. You don't want this line 12 by itself, because that would not give you points. You want the dot append, and in my case, I'm setting the one list to the values of another list. So that's good to go there. And in this case, I'm using the same screenshot for this second part, because I'm using the data shape.point list and the shape point list bracket I, 0, 1 for X and Y. So I'm using my list because the polygon copies those points over all except for one of them. So that's how my data is being used to manage complexity, is I'm copying all the data over except for one of them, and that's how it changes the shape in my video if you saw at the beginning. And then again, triple check at the bottom of the digital portfolio. I don't have a picture of it because I don't have the student view, but when you're dropping the images in, click on, at the bottom, scroll down the digitalportfolio.ap, classroom. Or college board, whatever the website is. Scroll down when you're uploading the PPR, and there's a button to click save. When you click save, it's not submit final, so don't worry, click save. You can click save again and again and delete the images if you need to redo it, and then click save again. But at the very bottom, there's a PDF. You can download a PDF and you can see it. You can print it out, and like I said, print out this one too, and then you can see if the font's big enough, because that's what you print out after you save. It'll be pretty much what it looks like. Oop, I ran out of time. On the AP exam day that your teachers will print out for you. So I think that's it. Have a good day.